Hello friends, how are you? I hope you all are well. A new day, a new beginning. Today, in this video, I am going to explain principle of superposition of charges, or you can say principle of superposition of Coulomb's forces. In my previous videos, I explained about the Coulomb's law. That means we studied how the force act between 2-point charges. In this video, we will discuss how the force act on a point charges if multiple point charges are present in that field. So I hope that you might have subscribed this channel. If you have not done, don't delay, because your subscription will inspire me. At the same time, it will help you a lot to get the videos as early as possible. So without delay, let us start. See here. So today's topic is principle of superposition of Coulomb's forces, or you can say principle of superposition of charges. Coulomb's law helps us to calculate the force between 2-point charges, but this principle enables us to calculate the force act on a point charge. Suppose your number of charge particles Q1, Q2, Q3 are there. Here is a point charge Q. All are the point charges we are discussing. So, superposition explain how much force act on a point charge due to all other point charges in that field. Okay? So, it is better I shall write what is the principle of superposition. So, I can say that principle of superposition states that the force, or I can say that when there are a group of point charges in a field, the force between 2-point charges is independent of all other point charges. That means if there are number of point charges in the medium, the force between the 2-point charges is independent of all other point charges present in that field. Or I can say that the force on a point charge is vector sum of all the forces. Vector sum of all the forces due to other point charges. That force can be calculated by vector sum of all the forces due to other point charges. This is about principle of superposition of charges or Coulomb's forces, I can say. Let us try to understand mathematically how force act on a point charge. So I shall write force on a charge. Force on a charge. Force on a charge due to a multiple electric charges. Due to a multiple electric charges. See that how force acting when multiple charges are present in a medium. See, x-axis, y-axis, z-axis, this is the origin. Suppose Q1 is a charged particle here. Q2 is the charged particle here. Q3 is one more charged particle. Like that, multiple charged particles are present in this space. Okay? Suppose Qn, like that Q1, Q2, Q3 up to Qn, large number of charged particles, multiple charged particles are present. Now you see that, suppose this is the, I can write R1 is the position vector of the charged particle Q1. I can write this is R2. Similarly, I can write this is R3. This is Rn. R1, R2, R3, Rn. These are the position vector of the charged particles Q1, Q2, Q3, Q4 like that. Okay? Now, I have to calculate force on a charge. Force on a charge, or I can say that force on a point charge due to a multiple electric charges. We will calculate how much force acting on the charge Q1. So, here Q1, suppose it is a positive charge, Q2 it is also positive charge. Definitely, the force which will act on Q1 due to Q2, I can write this is force on 1 due to 2. Like this I can write. Okay? Similarly, I can write that this is F on 1 due to 3. Or I can draw like this also. This is F on 1 due to 3. And Q to Q1, the distance I can mention R21 vector This one I can mention that R31 vector. Here to here I can mention Rn1 vector, because I have written that force act on a point charge is vector sum of all the forces acting due to all other point charges. Now we'll see according to Coulomb's law. So according to Coulomb's law, we know that F is equal to 1 upon 4 pi epsilon naught r square q1 q2. So this one we have studied in previous videos. Coulomb's law, 1 upon 4 pi epsilon naught r square, where r is the distance between two point charges q1 and q2. Like this we have studied. Now in this case we'll see that if it is in free space, how much force acting on the particle charge q1 by q2, I can write F12, this is equal to q1 q2 upon 4 pi epsilon naught r21 square r21. So this r21 represents the distance between the point charges q2 and q1, and this r21 represents the unit vector, which represents only the direction. Similarly, I can say that F13 is equal to q1 q3 4 pi epsilon naught r31 square r31 cap. Like that, number of charge particles are there, so they will also apply the force. But remember that how much force acting on the charge particle q1 due to q2, it is independent of other charges. It does not depend whether other charges are present or not present. First point I said that it is independent of all other point charges in that medium. So similarly, I can say that suppose this is the F1n, this charge particle. So I can say that this is q1 qn upon 4 pi epsilon naught rn1 square rn1 cap. So these are the forces acting on the charge particle q1 when number of charge particles present in that medium. Then what about the total forces? So I can say that this total forces, you can consider that this is the direction in which the total, this is the direction of the net force. This is the direction of the net force. When two charge particles are there, the force between them does not depend upon the medium, but the net force depends upon the medium. Remember this point also. So I can say that this is F12 plus F13 plus F1n. So this is the net force acting on the charge particle. If I add this one, I can say that this is 1 upon 4 pi epsilon naught. Here it will be q R1 Q2 upon R21 square R21 cap plus Q1 Q2 R31 square R31 cap plus Q1 Q1 n Rn1 square Rn1 cap. This is the net force acting on the point charge due to presence of multiple point charges. Let us see one example. It will be make you more clear. So I hope that you might have noted it. See. See, suppose this is an example. Three-point charges. These 3-point charges present at 3 vertices of an equilateral triangle. Suppose this is A, this is vertex B, vertex C. Okay? 3-point charges are there. All are equal charges. You have to calculate how much force act on any point charges. How much force act on any point charge. For example, we'll consider at this point. Yes, one more thing. The distance between all these distance between AB, AC, BC all are equal because I said that ABC are the vertices of an equilateral triangle. Suppose this distance is given A. So this is also A, this is also A. Now we see that how the force is acting. These 2-point charges, they are the identical charges. So definitely the force which will act, it will repel it in this direction. So I can say that the force on A due to B like this. Here also I can find that force on, so this is force on A due to C. This is force on A due to B. So these are the identical charges. So the force which is acting, it is repelling. It is also repelling. So definite the resultant force or the net force which will come, it will come between these two forces. Okay, first we will see that how much force acting at the point A. So I can say that force on A due to the charged particles at a B, this is equal to Q square, Q1 into Q2. I have written Q square divided by 4 pi epsilon naught A square. Similarly, I can find that force on A due to C, this is also Q square 4 pi epsilon naught A square. So both these forces we are finding equal, no doubt at all. Then what about the resultant forces? We know that this net force is due to F AB plus F AC. So I can find that its magnitude, the resultant force magnitude, will be equal to F AB square plus F AC square plus 2 into F AB into F BC cos theta. So I can write this is equal to, so F AB is equal to q square by 4 pi epsilon naught a square. F AC also same thing. That means I can say that this is q square 4 pi epsilon naught a square plus q square 4 pi epsilon naught a square plus 2 FAB FBC. That means q square 4 pi epsilon naught a square into q square 4 pi epsilon naught a square into cos 60 degree. You see, this is the equilateral triangle. This is cos 60 degree. So I can take the common q square 4 pi epsilon naught a square. Okay. So how much will be left? Here it will be left a 1 plus 1 plus 2 into cos 60 degree 1 by 2. That means q square 4 pi epsilon naught a square 2 to cancel. This is 1 plus 1 plus 1, or I can write this is root 3 q square upon 4 pi epsilon naught a square. So this is about to how much net force acting on the point charge particle present at the point A. What about the direction? So since the magnitude of forces FAB, FAC both are equal, so definitely the direction of the net force will divide it equally. That means it will make 30 degree angle along FAB, because this is an equilateral triangle. All these angles are equal since it is 60 degree, vertically opposite angle 60 degree, but this net force will divide it equally because the magnitude of forces FAB and FAC both are equal. So this is about the principle of superposition of charges, or you can say principle of superposition of Coulomb's forces. So I hope that you might have understood this video clearly. So until the next video, bye.